Now see next question from exercise 5.4, question number 9. Show that the vector area of a parallelogram ABCD is half of cross product of vector AC and vector BD, where AC and BD are its diagonal. So we have to show here, if AC and BD are the diagonals, then the vector area of this quadrilateral ABCD, which is parallelogram, is half of cross product of that diagonals. So first we draw here parallelogram. So we consider here, let quadrilateral ABCD is a parallelogram. So we draw here parallelogram first. So we draw here parallelogram ABCD, in which AB, BC are parallel, AD, BC are parallel, and BD and AC are the diagonals. So we write here A to B, D to C, A to D, B to C, then A to C, then B to D. So here first we find the value of vector AC. So we find AC. Therefore vector AC equals to vector A to B plus vector B to C, vector A to B plus vector B to C. Now here this vector AB parallel with vector DC, vector AB equals to vector DC, and this vector AD equals to vector BC, vector AD is equal to vector BC. Now see next diagonal is BD. So we write here, therefore vector BD is equal to B to D, we write as B to A to C, vector B to A plus A to D. So this vector BA can be written as vector AB. So we write this as minus vector AB plus vector AD. So we replace this vector AD by vector BC, because we required the area of this parallelogram. So we write this vector AD in terms of BC here, minus vector AB plus vector BC. So we write this as vector BC minus vector AB. Now see, we calculate the value of this vector AC cross BD first. So we find here, therefore vector AC cross vector BD is equal to. So substitute the value of vector AC as AB bar plus BC bar, vector AB plus vector BC cross vector BD as BC minus AB. So we write here vector BC minus vector AB. Now multiply these two brackets. So we first multiply by vector AB cross vector BC minus vector AB, then plus vector BC cross vector BC minus vector AB. Now multiply by vector AB, that is cross multiplication. So we write here vector AB cross vector BC minus vector AB cross vector AB. Now multiply by vector BC. So we write here vector BC cross vector BC, then minus vector BC cross vector AB. Now by the property of vector A bar cross vector A bar equals to 0 vector, so we replace this A bar cross vector AB cross vector AB as 0, and this vector BC cross vector BC as 0. So we replace this value by 0 vector and this value by 0 vector. That means remaining terms are vector AB cross vector BC minus vector BC cross vector AB. So we change this sign. For changing the sign, we have to rearrange these vectors. That means vector A bar cross vector B bar equals to minus vector B bar cross A bar. So we write this as vector AB cross vector BC plus vector AB cross vector BC. These two are same. So we add these two, a vector AB cross vector BC, which is equal to vector AC cross vector BD. Now we can transfer these two to left hand side. So we write here 1 by 2 vector AC cross vector BD equals to 2 times. We transfer these two to left hand side. So we write only vector AB cross vector BC. Now this is area of parallelogram, and AB and BC are the adjacent sides. AB and BC are two adjacent sides. So this is area of parallelogram, or we can write area of parallelogram ABCD. That means this is area of parallelogram ABCD, but AC and BD, here AC and BD are the diagonals. So we say from this conclusion that the vector area of parallelogram ABCD is half of vector AC cross vector BD, where AC and BD are its diagonal. So in this way you can show area of parallelogram ABCD equals to half of cross product of the diagonals of the parallelogram. Now see question number 10. Find the area of parallelogram whose diagonals are determined by the vectors A bar equals to 3i minus j minus 2k and B bar equals to minus I plus 3j minus 3k. Here diagonal vectors are given. So we use the formula area of parallelogram whose diagonals are A bar and B bar. So we write here area of parallelogram having diagonal vectors A bar and B bar equals to. So we write here area of parallelogram having diagonal vector A bar and B bar. In previous example we proved that area of parallelogram is equal to half of cross product of the diagonal vectors. So we write here half of cross product of diagonal vector. So diagonal vectors are A bar and B bar. So we write half of and magnitude of A bar cross B bar. That means we have to find first A bar cross B bar. Then we have to take its half value for the area of parallelogram. So first find A bar cross B bar. Therefore A bar cross B bar equals to, in first row we write ijk, in second row we write the coefficients of ijk of vector A, that is 3 minus 2, 3 minus 1 minus 2, 3 minus 1 minus 2. Then coefficient of ijk of vector D, so write minus 1 3 minus 3 minus 1 3 minus 3. So we calculate this first. So we get here I into minus 1 into minus 3, that is plus 3 minus, so minus minus get plus 2 into 3 we get 6 minus j in bracket 3 into minus 3 we get minus 9 minus then minus and this 2 minus sign so we get minus 1 into 2 is 2 then plus k cap into 3 into 3 is 9 minus again here both are minus so we write 3 times minus so we write minus 1 into 1 is 1 so 3 plus 6 9 so we get 9 and minus 2 minus 9 minus 2 we get minus 11 minus minus plus so we write 11j plus 11j then 9 minus 1 we get 8 so we write 8k. This is value of a bar cross b bar. Now we have to find the value of a bar cross b bar, its magnitude, that means magnitude of a bar cross b bar. So use this value in this formula. So before using the value we calculate its magnitude. Therefore magnitude of a bar cross b bar is equals to square root of 9 square plus 11 square plus 8 square. So we get 9 square 81, 11 square 121, 8 square 64. So after adding this we get 266. Now this is the value of magnitude of a bar cross b bar. So we write the formula. Therefore area of parallelogram is equals to half of a bar cross b bar, that is equals to half of square root of, and this is area so we have to give unit square unit. So in this way we calculate the area of parallelogram if diagonal vectors are provided. Now see question number 11. If vector A, vector B, vector C, vector D are four distinct vectors such that a bar cross b bar equals to c bar cross d bar and a bar cross c bar equals to b bar cross d bar, prove that a bar minus d bar is parallel to b bar cross c bar. So what we have to do here? So first we discuss that we have to show these two vectors are parallel. When two vectors are parallel, if their cross product is 0, that means we have to show here, that is to show a bar minus d bar cross b bar minus c bar equals to 0 vector. That means our aim is to show the cross product of a bar minus d bar and b bar minus c bar equals to 0 vector. So we use the given condition. First condition is this vector a, b, c, d are distinct vectors. So we write here in solution since vector a, vector b, vector c, vector d are distinct vectors, therefore a bar not equal to b bar, not equal to c bar, not equal to d bar. Now we require vector a bar minus d bar, so we take here a bar not equal to d bar, that is a bar minus d bar not equal to 0 vector. Similarly, we require b bar minus c bar, so we write b bar minus d bar, b bar not equal to d bar, that is vector b bar minus d bar not equal to 0 vector. Now this is first condition, and second condition is these vectors are such that a bar cross b bar equals to c bar cross d bar, and second a bar cross c bar equals to b bar cross d bar. So we take the vector in the form of a bar minus d bar, b bar minus c bar. So we use this second condition. So we write this as we denote that A bar cross B bar is equal to C bar cross D bar as equation number second. This condition we write as equation number 1, and this A bar cross C bar is equal to B bar cross D bar. This is as equation number 3rd. Now we subtract this equation second from equation number 3rd, or we can subtract equation 3rd from second. So we write here subtract second. We write here subtract 3rd from second. So we have to write this as A bar cross B bar minus A bar cross C bar is equal to C bar cross D bar minus B bar cross D bar. So we take here A cross common, so we write vector A cross B bar minus here C bar is equal to. Now here we can take vector D common. So first we write here this vector as minus B bar cross D bar plus C bar cross D bar. We write this second vector at first position and this first vector at second position. Now take the vector cross D bar common. So we write here vector cross D bar common, and we take minus sign again common. So we write here vector B bar minus vector C bar. Why we take here minus sign common? Because we write the vector. If we observe the LHS, B bar minus C bar, here we require B bar minus C bar, so we take minus sign common. So you can write this as, so we use here this D bar cross B bar minus C bar, because when we interchange vectors, A bar cross B bar can be written as minus B bar cross A bar. So we interchange these two vectors. We write this vector D at first position and this vector at second position, and here is cross multiplication. So we change this minus sign to plus sign. Now transfer this RHS to left hand side. A bar cross B bar minus C bar. So we write here A bar cross vector B bar minus C bar. After transferring this to left hand side, we get minus B bar cross B bar minus C bar. Therefore, in RHS we get 0 vector. Now take common cross B bar minus C bar. So taking B bar minus C bar common. So the remaining vectors are A bar minus B bar is equal to 0 vector. Now we get the cross product equal to 0 vector. That means these two vectors are parallel vectors. Therefore, A bar minus D bar and B bar minus C bar are parallel vectors, and that we have to show. So when we have to show the two vectors are parallel, we show their cross product equals to 0 vector. Now say next question number 12. If vector A equals to I plus J plus K and vector C equals to J minus K, find a vector B satisfying A bar cross B bar equals to C bar and A bar dot B bar equals to 3. That means we have to find vector B, and these two conditions are given and value of vector and vector C is provided. So we first write here in solution, let vector B equals to xi plus yj plus zk. That means the vector which we have to find, that is vector B, we consider here xi plus yj plus zk. That means we have to find the value of this x, y, z. For that, these two conditions are given. So we use this first condition, A bar dot B bar is equal to 3. which is given. So substitute the value of vector A, that is I plus j plus k. Then substitute the value of vector B, which we have to find. So we write here xi plus yj plus zk is equals to 3. So take dot product here. So we write directly x into I dot I, that is 1. So we write x plus y plus z is equal to 3. So denote this as equation number 1. Now we use this second condition, a bar cross b bar equals to c bar. So we write this as c bar is equals to a bar cross b bar. Now substitute the value of vector c, which is j minus k is equals to, now we have to find the value of a bar cross b bar. So we write here I j k. Then we have to write the coefficient of vector a. So the coefficient of vector a are 1 1 1 of I j k, 1 1 1. Then coefficient of vector in vector b of I j k are x y z. So we write here x y z. Now we have to calculate this determinant. So we write here plus minus plus. Now calculate this determinant, which is equal to I 1 into z is z minus 1 into y is y. Then minus j into 1 into z is z, z minus x into 1 is x. Then plus k in bracket. 1 into y is y minus 1 into x is x. So we write here y minus x. So we write this as, in left hand side, first we write this as 0i plus 1j minus 1k, because we equate both sides, that is by equality of vectors. So we write here by equality of vectors, by equality of vectors, we write z minus y equals to 0, z minus y equals to 0, that is z equals to y or y equals to z. Then from this second we write here, so when we have to multiply by minus sign, here is plus, so we equate this as z minus x equals to minus 1, z minus x is equals to minus 1, that is we get here, or x in terms of z, we write x plus, here when we transfer this plus x to right hand side, so we write one step more, z plus 1 is equal to plus x, that is x is equal to z plus 1. Now last is y minus x. Here coefficient of k is minus 1, so minus 1 is equal to y minus z. Minus 1 is equal to y minus x. So we transfer this x to left hand side, so we get x is equal to y plus 1 or 1 plus y. Now we denote this as equation number second, this as equation number third, and this as equation number 4. Now we replace the value of y in terms of z, then x in terms of z in equation number 1. So put y is equal to z and x is equal to z plus 1 in equation 1. Therefore equation 1 becomes, in place of x we replace z plus 1, so we write z plus 1 plus y. So in place of y we replace z plus this z as it is equal to 3. Now add the terms of z plus z plus z, that is 3 times z is equal to, after transferring this 1 to right hand side, we get 3 minus 1, which is equal to 2. That means z is equal to 2 by 3. We get z equal to 2 by 3. And we have from equation second y equals to z. So we write y is equal to z is equal to 2 by 3. That means y is also 2 by 3. Now we have to find the value of x. So substitute this value of y in equation number 4 or equation number 3. Therefore, from equation 3, we have equation 3 as x is equal to z plus 1. Value of z is 2 by 3. So 2 by 3 plus 1, we get 5 by 3. So in this way we get the value of x, we get the value of y, we get the value of z. So we consider here a vector b in the form of x, y, z. So we write here, therefore vector b is equal to x is 5 by 3, 5 by 3 and plus 2 by 3 j plus 2 by 3 k. So in this way we find a vector b by using the given conditions a bar cross b bar equals to c bar and a bar dot b bar equals to 3.